Jai Hind. Myself Pushkal K, Shukla, Assistant Professor in Computer Science Department at Akgec Engineering College, Ghaziabad. Today I will discuss a topic, Introduction to Set Theory. This topic is helpful to the B.Tech third semester students. The topic objective, basically here we will discuss about the introduction about the sets. So these sets are used to define the concept of relation and function. This study of geometry, sequence, probability, etc. requires further knowledge of the set. The students will demonstrate the ability to the use of set to codify mathematical objects. And also the students are able to represent a set using set builder form as well as a roster form, examples of finite and infinite sets, and build new sets from the existing sets using various combination of the set operations like intersection, like union, like difference and complement, etc. And also determine two sets are equal by determining whether each is a subset of the other or not, and also able to identify the difference between the equal and equivalent sets. Now come on the topic, a set. A set is a defined as a well collection of is a well defined collection of distinct objects of the same type or the class of the objects. It means ki set is a well defined collection of objects. Come on the well defined collection of objects, well defined collection of objects, distinct objects. There is a term distinct objects, well defined collection of distinct object. What is mean actually? Suppose for example, a set of river of India. So set of river of India is well defined. From these examples, we can identify these are the elements of the set. For example, Ganga, Jamuna, Saraswati, Godavari, Narmada, Trapti, etc. These are the rivers of India. So if we say a set of rivers of India, definitely we are going to identify these are the particular elements which belongs to this set. So everyone can identify this. So this is well defined. And collection, basically what we do, that we collect into one place. In set theory, we write into the curly braces, and curly braces just like as a box in which elements are there. Second, if you talk about the set of vowels, so definitely everyone knows A, E, I, O, U are the vowels of the English alphabet. So everyone understand the elements of this set. So it is a well defined collection. This is a well defined collection of distinct objects. A, E, I, O, U. Distinct objects means repetition is not allowed. And also important, ordering is not important. You can write 1, 2, 3, yeah 3, 2, 1. Ordering is immaterial. Ordering is unordered. So if it is unordered, yeah, sequencing is not there. So if you use in a Python language, then indexing does not work. In array, in C, indexing works. Then A0 first element, A1 second element, A2 third element and so on. But in set theory, if you use in Python language, then indexing does not work on this set. Distinct objects means repetition are not allowed. It means if we allow repetition, then it is immaterial. We allow, but this is the case of the multi-set actually. In multi-set we allowed, but in a set simply we do not allow repetition. So well defined collection of distinct object is a set. Another example we see, intelligent student of the class B.Tech second year. CS branch. So it is difficult to identify whose guys are intelligent one and who is not intelligent one. Different parameters are there to judge this particular student is intelligent or not. So it is very difficult for everybody to tell which student is intelligent and which student is not intelligent. So in this situation, we have to identify intelligent word clearly. If we define it intelligent, those guys are intelligent who having 75% marks in a 12th standard examination or comes under the category of intelligent. So at this situation, everyone can identify these are the elements, yeah, these are the students which comes under this category are the intelligent one. Another example, good batsman of the Indian cricket team. So it is very difficult to say good batsman. If you clarify it, good batsmen are those who having 20 centuries in one day and 20 centuries in 5-day match, then everybody can clearly identify these are the cricketers who comes under the good batsman category. So we conclude set is a well defined collection of distinct object. All the terms are clear. Next, we broadly denote a set by the capital letters ABC. Generally, set names can be written in a capital letters A, B, C, X, Y, Z, etc. And the element of the set, a member of the set is written in small letters, lower case letters like A, B, X, Y, Z, etc. Suppose A is a set and A is a set and small a is element of this set, then we can say A is element of set A. And also we can say B is not element of set A. So this symbol, Greek symbol, is an element of, it denotes as is an element of. So here we can say A, this A is element of A, set A. This capital letter name is set A and A is element of this set A. So A is element of set A, A is a member of set A, A belongs to set A. Similarly, B is not there in set B, so we can say B is not element of set A, B is not element of set A, B is not a member of set A, and B does not belongs to set A. Set representation. Two types of representations are there. First one is roster or tabular form and second one is set builder form. So roster form, in this form of representation, we list all the elements of the set within the braces and separated them by commas. For example, set of vowels of English alphabet. So set of vowels of English alphabet is just name as a set A equal to vowels of English alphabet written as A, E, I, O, U. A, E, I, O, U. List one by one element separated by comma and enclosed within a braces. This form of representation is known as roster form or tabular form. Another example we see, set A of all odd numbers less than 10. So A is a set of all odd numbers less than 10, 1, 3, 5, 7, 9. like this. So what we are doing here, we are listing all the elements one by one, separated by commas and enclosed within a braces. So this is the example of roster or tabular form. Second representation is set builder form. In this form of representation, we will list all the elements by listing the properties. We categorize all the elements by their properties. For example, suppose x is an even number. Suppose set of even numbers. So how we can represent into the set builder form, like a equal to x such that x is an even number. Yeah, we can write also like this, a such that x is equal to 2n, where n is element of whole number. So we can get a even number by putting w equal to 0, that will be 0, the w equal to 1, that is 2, w equal to 2, that is 4, and so on. So 0, 2, 4, 6, 8 up to. So by this we can represent both way we can write it is in a set builder form. Another example we see, like b equal to 2, 4, 8, 16 and 32. So how to represent this into the set builder representation? So here we see the correct, this we can write here as a 2 k power 1, 2 k power 2, 2 k power 3, 2 k power 4 and 2 k power 5. This is the way. So how we can write this in the set builder form, like b equal to x such that x is, what is going on here, 2 k power 1 that is 2, 2 k power 2 that is 4, 2 k power 3 that is 8. So we can write here x equal to 2 k power n. This is 2 k power n, where n is element of n, natural number. So we write here n is natural number, and n lies between 1 to n to 5, like this, 1 to, like this one, not this. Next is standard notations. Standard notations, x is element of a, this symbol represents belongs to a, element of a and member of a. X does not belong to a, you are not a member of a, you are not element of a, this symbol. This is a phi that is empty set. Empty set means phi, it can be also written as this is also an empty set. Yeah, like this. In a set having no elements, that is empty set. Universal set representation, capital U, we write here as a capital U. The set of all natural numbers represented by n, and the set of all integers is represented by I या Z, capital Z. In some books जो है I, and in some book refers capital Z. I naught, the set of all non-zero integers, and I plus represents a set of all positive integers. C represents set of all complex number, and C naught represents a non-zero complex numbers. And similarly, Q is a set of rational numbers, Q naught is a non-zero complex rational numbers, and Q plus is the positive rational number. And the same way R naught and R plus are defined, the set of real numbers, the set of non-zero real numbers and the set of positive real numbers. Cardinality. The total number of unique elements in the set is called the cardinality of the set. Total number of unique elements. Like A equal to A, B, C. So cardinality of set A is 3 and it can be represented by number of elements in set A. Yeah, we can write here a cardinality of A like this. Yeah, we can write also like this, cardinality of A equal to 3. If a set A having A, B, C and A, so repetition is not allowed, we avoid to use repetition, we do not allow in the set. If someone allowed, so this is the example of like multi-set. So in this case what we will do, cardinality of this A is also, cardinality of A is also 3. The set A of all non-negative even integers. So in this case the element of the set is 0, 2, 4, 6, 8 and 10 and dot dot dot. So cardinality of this cannot be measured, we cannot count by the natural numbers. So this is countably infinite set, countably infinite set is the cardinality. Talking about the types of the set, set can be classified into many categories, some of which are finite, infinite, subsets, universal, proper, power, singleton, etc. The finite set, a set A is said to be finite if it can be counted by the natural numbers. For example, A equal to 1, 2, 3, so it can be counted by natural number 1, 2, 3, 3 elements are there, cardinality is countable here. So this is the case of the finite set. Cardinality of the empty set is phi, sorry, cardinality of empty set, yani phi equal to 0, cardinality. And cardinality of this equal to 1. There is a difference actually, phi is what? Phi is this and cardinality of this is 0 and cardinality of this is 1. Yani this is the case of the singleton set. Set of even positive integer is not a finite set, it is a countably infinite. Because we cannot map one-to-one correspondence with the natural number. That's why it's not a finite. Infinite set, a set which is not finite is called an infinite set. For example, set of even numbers, set of odd numbers, set of natural numbers, set of prime numbers, set of and many more. Uncountable infinite, a set which is not countable is uncountable infinite set, or non-degenerable set, or simply uncountable. Yani set of all positive real numbers less than 1. It means a positive real numbers less than 1 it is the case of the uncountable infinite. Subsets. If every element in a set A is also an element of set B, then A is called a subset of B. It can be denoted by this symbol and written as A is subset of B. Here B is called superset of A. For example, A equal to 1 2 and B equal to 4 to 1. So every element of A, every element of set A is in set B. So we can say A is subset of B. Yeah, we can also write B is a superset of A. Properties of subsets. First property, every set is a subset of itself. Yani suppose A equal to 1 2. So 1 2 1 2 is a subset of 1 2. Every set is a subset of itself. So it means ki 1 2 1 2 is a subset of 1 2. So every set is a subset of itself. So we can say A is a subset of itself and A is a improper subset of itself. Subset, but it's improper. If equalities are there, then we can say it is an improper subset of itself. The null set phi is the subset of every set. Very important. Phi is the subset of every set. And if A is a subset of B and B is a subset of C, then A will be subset of C. We can see by example, suppose A equal to AB and B equal to ABC. So here we see कि A is a subset of B and similarly C equal to A, B, C and D. So here B is a subset of C. So both conditions are satisfied here. A is subset of B and B is a subset of C, then A will be subset of C. So here AB is also in this C set. So AB is also there. So we can say A is a subset of C. So what third property is, if A is a subset of B and B is a subset of C, then A will be the subset of C. And next, fourth is a finite set having n elements has 2 to the power n subsets. We can see by examples. So suppose A equal to set having A and B. So the subsets are, first the phi is the subset of every set. So first element should be phi. Then phi means what? Out of two elements we are picking nothing, yani no elements. So phi. Then picking one elements, then it will be A and B, and picking two elements, that is AB. So 1 2 3 and 4 elements are there. The 4 subsets are there of this set A equal to AB. So 2 ke power 2 yani ki 4 subsets are there. If there are 2 elements in a set A, so 2 ke power n, where n equal to 2 here, so 2 ke power 2, that is 4 elements should be there in the subset. If there are 3 elements in a set A, then 2 ke power 3, 8 elements should be there in subsets, and these are, suppose 1 2 3, yeah, A B C, 3 elements are there, then phi A B C, A B A C, A B A C B C and A B C. So all 8 elements are there in this. All elements, yeah, all subsets are the subsets of this set. So 2 to the power 3. In the same manner, if n elements are there, in a set A, so total number of subsets are 2 to the power n in a subset. So a finite set having n elements has 2 to the power n subsets. Then come on the proper subset. If A is a subset of B and A equal to not B, then we can say A is a proper subset of B. For example, A equal to 1 2, right, and B equal to 1 2 3. So all the element of A is in B. All the element of A is in B, but A equal to not B. So this is the example of proper subset. And if A equal to 1 2 3 and B equal to 1 2 3, right? So this is also the subset, but it is not a proper subset. If all the element of A is in B and A equal to B, so this is the example of improper subset. So there is a difference between the proper and improper. Thank you.